Hello students, today we are going to start the first lecture of the basic chemistry for the engineers. In the first lecture we are going to study the development of the atomic theory, and let me first give you the outline of the first few lectures of the course as well. In the first we are going to study the observation that lead to the belief that atoms are the most basic constituent of matter. And then we are going to see the experiments and observations that enable us to believe that atom is not the most basic constituent of matter, and we can divide the atom into at least electron and the nucleus. Then we are going to see the fundamental principles that allow the electron and nucleus to remain together in the atom. That is, we are going to see the structure of atom, and we are going to see the failure of classical mechanics to explain this structure of atoms. And definitely we are going to look into the new kind of mechanics, that is quantum mechanics, to understand how these electrons and nucleus they stay together in the atom. After studying the structure of atom, we are going to see that how two atoms they can join together to form compound and molecules. And further, there are also some kinetics and thermodynamics involved in the course. So, starting to discuss the discovery of the atom, or you can see the concept that matter is composed of the discrete units. First comes the ancient Greek philosopher. They were certainly pondering over what is matter and how it is made up of. So there was one of the philosophers which is called as Aristotle, and he was of the belief that matter is a continuum, and if you have some, for example, solid material, you can divide it, and there is no limit to it. And you can divide it to the smallest unit, and there is no particular limit from where you have to stop dividing it. So he said matter is divisible and there is no limit to it, and this is called as the continuum theory of matter. For example, if you have this matter and you can divide it from anywhere and not fixed boundary, and you can divide it, there is no limit to it. So this is a continuum. So this was one of the philosophies by ancient Greek philosophers. On the other hand, there was another theory which is called as the discrete theory of matter. So this was also held by another philosopher who is called as a Democritus, who was actually 100 years older than Aristotle. And he said that matter is composed of some smaller units which are called as the discrete particles, and these discrete particles are called as atomos. A means not and thomos means divisible. So this is called as a discrete theory of nature. For example, let us consider this diagram where you see this is the matter and it is composed of small units which are called as the atoms. These units have definite boundary and they have definite mass. That's why they are called as discrete. So according to the Democritus, you can divide this matter and you can divide it until you reach this basic unit, and you cannot divide this atom. If you divide this atom, the matter will lose its properties and its quality. So this is the limit from till which you can divide the matter. In the Aristotle philosophy, that is in the continuum theory of matter, you can, if you consider the continuum theory of the matter, you can even divide. There is no discrete particle, there is no boundary. But according to the Democritus, you can reach to this atom and you cannot further divide it. So after the 4th and 5th century BC, there was not any evidence for any of these philosophies. But for some reasons, it was Aristotle whose continuum theory of matter, it prevailed all the way to the 17th century. But then in the 17th century, there were some observations and some experiments which led to the belief that the matter was not actually behaving like it has a continuum nature. Rather, it was behaving like it has some discrete nature to it. So now we are going to see that what are these experiments and what are these observations. So there was a set of observation that matter was not really behaving and reacting like a continuum. It was behaving more like it has some discrete nature to it. So first of these observation was Robert Boyle. He was a theologian, and he gave the idea of the element, and he said that element is the smallest or certain unmingled body in the matter, and if the two unmingled bodies or two elements they combine together, they form a molecule or compound. So since the elements have boundaries and they have certain mass, so it means they are discrete. And if the matter is composed of elements, then the matter has discrete nature to it, it's not a continuum. So this observation, which was observed by scientists as well when they were reacting certain materials, so they observed that the matter must have some elements, some basic units. So it was representing the discrete nature of the matter. Then there was a scientist, Lavoisier, who gave the law of conservation of mass. He was actually studying the reactions in the air from which the nitrogen was removed. And he actually wanted to see whether this air, which has predominantly oxygen in it, whether this oxygen is adding into the reactant or not. So what he did, he measured the mass of the reactants and he measured the masses of the product, and he found out that this oxygen was actually adding into A and B to form products. So he gave the law of conservation of mass, that is the mass of the reactants was equal to the mass of product. But from this experiment, he also understood that matter has some discrete nature because he was measuring the mass of these discrete particles, these discrete units. So they can have masses if they are discrete elements or they are discrete units. So this again shows the discreteness of the matter. So he was also one of the first people who realized that the chemical reactions, they can be written down in the form of the algebraic equations like this, and he identified several 17 metals and 9 nonmetals as elements as well. Then there was another scientist who was called as J.L. Proust, and he gave the law of constant proportion. And according to this law, he said that when two elements combine, they always combine in definite proportions by weight. That is, the one atom of oxygen with a certain weight will combine with two atoms of hydrogen with certain weights, and they can form water. And in all the water molecules, you will have this fixed proportion. So again, this fixed proportion thing, the fixed weight thing, it represents the discreteness of the matter. So again, it's pointing out towards the discrete nature of matter and not the continuum nature of matter. Then there was an English scientist, school teacher, John Dalton, and he gave the Dalton's atomic theory. So he was aware of the observations of Boyle, Lavoisier, and Proust, and he realized that he can understand these observations if we go back to the Democritus idea of the atoms, that matter is composed of the discrete particles called as atoms. So based on this, he set forth some postulates, and which were later on called as the Dalton's atomic theory. So what was these postulates? He said that each element is composed of atoms. For example, if you see this copper, it is an element and it is composed of copper atoms that are identical. So atoms of this element are identical. Compounds are formed when the atoms, they react together. Atoms of different element react together. For example, the atoms of this copper element, it can react with the oxygen in the air to form copper oxide. And from the Lavoisier's observation, he said that atoms cannot be created or destroyed. He said that because in the Lavoisier experiment, he observed that the mass of the reactants were equal to the mass of the products. That's why he said that atoms cannot be created or destroyed. Although now we know that atoms can be divided into smaller units and they can be destroyed, but not in the chemical reactions. So Dalton did not do any of the experiment himself. And these postulates, they were not accepted immediately. There was a lot of effort for making the scientists and people understand that matter has a discrete nature. But nowadays we can even see the atoms or its boundaries, or we can image the atoms with a special microscope which is called as the tunneling microscope, scanning tunneling microscope. Now let us see that what is the setup in the tunneling microscope and how does it works. So scanning tunneling microscope actually has a tip of the tungsten metal. This is a sharp tip, blue triangle. You can see tungsten is represented by W. And this tungsten tip is basically attached to a special kind of material which is called as the piezoelectric material. Now this piezoelectric material has a special property that it can expand a little bit, meaning 10 to 20 angstrom, if the voltage is applied to it. And there are a lot of piezoelectric materials, like it can be quartz or barium titanate. So what happens in the scanning tunneling microscope, let's suppose we have a platinum surface onto which we have CO molecules that are adsorbed, and we want to see the shape of these atoms, these oxygen atoms on the top. So what happens in this microscope, we apply a negative potential to this tungsten metal, and because you know that this is a metal and it has free electrons in it, if we apply the negative potential to it, these electrons will get more energy and they will want to move to the lower energy states. So since this platinum is grounded, so it means it's at the comparatively positive potential as compared to the tungsten metal. So these electrons, they want to go to the platinum surface, and if they travel from tungsten to the platinum surface, then the flow of electrons will happen, and the flow of electrons is called as a current, which can be detected by the use of this emitter, which is connected in this circuit. Now the problem is that we have a space between this tungsten metal and this tip of the oxygen atom on the platinum surface. But in the scanning tunneling microscope, these electrons, they can flow to the platinum surface, overcoming this small distance of 5 angstrom. So this actually happens because of the certain phenomena which is called as tunneling, that we will see that what is tunneling. And this is the setup which is present in the scanning tunneling microscope, and we will also see that how it works. So let's first see that what is tunneling and how does the electron move through this small space of 5 angstrom. So that is a quantum mechanical effect, and this is because of the wave nature of electrons. The electrons are not just particles, they have the wave nature associated with them. So again, let's consider if this is the tungsten tip and this is a platinum metal, and you have electrons in this tungsten tip, and if they are particles, they cannot cross this space. However, if they are wave, then you can see a part of this wave, it can travel to the platinum surface. So this effect is known as a tunneling, that is the passing of electrons through the small space because of the wave nature, and it's a quantum mechanical phenomenon. So because of this thing, in the scanning tunneling microscope, the electrons in the tungsten tip, they can move to the platinum surface and the current can flow in the whole setup. So how does this setup? It images the surface of atoms. It creates the image of the CO molecules or the atoms. So if you apply certain voltage on this piezoelectric material, you can move this tungsten tip to a little bit away from here. So when this tungsten tip was closer to the CO molecule, we had a certain amount of current flowing, which is indicated by the emitter. If you move this tungsten tip here, then you see the distance of the CO molecule with this tip will increase, and as a result you have a decrease in the current in the emitter. Again, if you move it towards here, the yellow triangle, then again because of this distance will decrease, and again you will see an increased current. So this current which is coming on the emitter is fed into the computer, and the computer, it creates an image of the surface based on the intensity of current. So what you see an image like this. For example, here you see the maximum current because the tip is closer to the molecule. Again it moves away, then you see a decrease in current and then increase in current, and it's like this. So on the surface you create an image of the atoms or the molecules on this platinum surface. So that's how the scanning tunneling microscope, it probes the surface and records the image of the atoms on the surface. So in this lecture we have seen that how people believe that the matter is composed of the smallest units, and these smallest units are called as atoms. But now we know that atoms are not the smallest unit, and we can divide them into further smaller units. So in the next lecture we are going to see that atom is not the most basic constituent of matter, and we will also see the experiments that lead to the discovery of the electrons and nucleus. Thank you.